So listen, we have a team that's been together for decades when you really think about it. A lot of the team that came out of Gluster is now at MinIO, and it allows us to move very, very quickly with a relatively small team and to innovate across a number of different things. We've picked 3 to talk to you about today, but we could have picked 12 and used our entire session on this. We're going to start with VMware because, again, it's so important to the overall story, and they are the private cloud, really, when you think about it from an enterprise perspective, and they picked MinIO, and I think that's a really important point to point out. When they were looking at this a year ago, before they, kind of nailed down who they wanted to go to market with, they had a huge challenge on their hands, right? Their customers were containerizing workloads that were previously basically done in virtual machines. It was an existential moment for them, but they knew it was their birthright to have the containerization and the orchestration component of it because it really fit so well with what it is that they did. But they had to take that challenge head on, and they had to build a platform that was as good at containerization and orchestration than it was at virtual machines. And that was a huge challenge for them. It demanded them to go back and really look at their operational chops and then adapt that to automation, to self-service, and to seamless interoperability across a bunch of different hardware platforms. And they did that, and we give them full kudos. I mean, this is a company that went and turned the entire ship and bet the company on it, and it's paying off for them already. And so it actually made them change their mentality as well, because when you think about it, this is a fundamentally different problem. And AB referenced it earlier, right? This isn't 100 VMs every 3 months. This is 1,000 containers 3 times a day. And so the lines between sort of that production and development world really do blur, because everything that you're doing, maybe, quote, in development, is designed to be in production within an hour, not within, a month. And so it's a different mentality, and they've embraced that. AB, why don't you take us through sort of what they've done and how they built MinIO into that equation?
Sure. Yeah. And what we liked about VMware's approach was they did not retrofit a Kubernetes stack on top of existing VMware deployments. Sure, you can install Red Hat Linux operating system on VMs and install OpenShift or one of the Kubernetes distro on any of your existing VMware environment, right? When you do that, you would ask then yourself, why not? If all I want is Kubernetes, then why not run RHEL on bare metal and then modernize everything with OpenShift like one of these Kubernetes distros? What's the advantage of putting Kubernetes on top of Vsphere? There won't be any, right? And that's not what VMware tried to achieve here. And that's what attracted us too. They actually got it right. And their goal is when Kubernetes comes into VMware, it has to be better than a stock Kubernetes running on a standard Linux operating system. How did they get this right? While Kubernetes brings the API-based infrastructure automation, treating infrastructure like code with everything communicated through APIs, and Kubernetes is not really designed just for containers. It is just any resource in your infrastructure is just an object and you can communicate with it. And that object could be a software network, or it could be an object store, or pretty much any part of anything, right? Even VMs, right? Application VMs. And this is actually something that VMware, when they did it right, the way they did it, they acquired the founders, the creators of Kubernetes into the company, and that brought the right vision inside. And as a result, right, what they did was they brought best of VMs and best of Kubernetes together in a way that you are not compromising both sides. It's not like a hybrid bike strategy, right? Where it's not the best road bike or not the best mountain bike. In this case, the way they did it, Kubernetes style API-based orchestration that now use that to manage VMs and containers alike. But from the VMware side, from the Vsphere side, VMware already had technology that the containers are as light, the VMs are as light as containers. But then you get true resource isolation that's still pretty weak when it comes to a stock Linux kernel-based kernel-based containerization. So VMware also has the software-defined networking and all the benefits that you already have, ability to easily manage the physical to container or physical to virtual layer, all from your vCenter. Those goodness comes into Kubernetes, so you can actually manage the the Kubernetes environment without learning to spell Kubernetes, to me, is actually a true innovation. It's a true benefit you bring to the Kubernetes. But now when you do that, now what does it mean for us? Now, what you see in the Vsphere 7.2 update 1 onwards, MinIO is bundled as part of the Vsphere. And inside Vsphere, there is a special Kubernetes cluster that's running all the time. They call it Supervisor Cluster, and that's what you see here. And once you upgrade to the Vsphere 7.2 update 1, on the vCenter console, you will see a demo shortly. You will see a MinIO plugin. Once you activate that, you will be able to communicate with the MinIO tenants inside, running inside of the supervisor cluster. Just to explain what a supervisor cluster is, supervisor cluster is basically a stripped down Kubernetes running directly on top of the ESXi host, not like the typical like Red Hat Enterprise Linux and OpenShift type like nesting. This is not nesting. It is actually MinIO running close to the ESX, as close as it can get. And we have fast local access to the drives underneath, and you get a real high performance data store. And here, I actually like how VMware positioned object storage. VMware got the right understanding of what an object storage should look like in the data, in the modern cloud native stack. They call it as a data store. And it is true that Cassandra or Kafka or any of these key value metadata store and an object store like MinIO are no different. They are all persistent services. In Kubernetes terminology, they call it stateful services. They are just like any other containers, but they have states. They need to be managed differently, and they have an operator. So VMware basically gave access to the core infrastructure in a way that we need not make any change to MinIO. That was what was the highlight for us. That if we had to re-architect MinIO to make compromises in a way that we have to have two variants, two forks, that one is VMware compatible and one is Kubernetes compatible, it would break the very design philosophy and advantage of MinIO. Instead, VMware did it in a way that they would bring all the architectural changes necessary at their side, and MinIO would run unmodified, which means it is truly cloud native when it's running on the VMware infrastructure.
In terms of who you see deploying this, are you seeing customers that are already MinIO customers or have deployed MinIO now looking to move to Tanzu with your support due to those day two operations? Or is it a new set of customers that are kind of fresh face and coming to Kubernetes that are going, let's do this right, let's do it with Vsphere? So who are the customers? Are they transferring from doing it one way, or are they new customers?
Yeah, actually, that is a great question. And what we are seeing here is all the adoption that MinIO got into the enterprise, but if you ask the same enterprise organization, the IT side, right, they probably won't even be aware that there is MinIO running inside their company. They only get to know when the scale reaches a critical point and it's in production environment. Now, IT has to keep things up and running. They have to be responsible for security, compliance, like even open source license violations, all of that, IT still takes care. Applications team as a shadow IT, they sneaked everything underneath and it reached production stage. And that is the point that IT gets to know, right? But then what we are finding today is the applications team is running MinIO on top of VMware without IT's blessing. And then at some scale, IT recognizes that, and sure, they come to us and they become a customer. But this step was an important step. Otherwise, IT was forced to run like a standard, like OpenShift or Rancher or one of those Kubernetes environment on bare metal, and IT hated it because they did not know how to manage bare metal infrastructure, and it's a step backwards for them, and they're right about that. This is where that by bridging the Vsphere and bringing Kubernetes support natively, the transition that will happen is finally the applications team will hand off data infrastructure to the IT, and IT can manage a private cloud infrastructure that is compatible with the public cloud, and giving object storage like S3 and compute like EC2, exactly like how Amazon gives. That infrastructure now will get transferred to the applications, to the IT team, without relinquishing control. That application team can continue to self-service themselves through the standard Kubernetes APIs, but managing the physical to container layer will get transferred to IT. So it's a transfer of power responsibility is going to happen. That is what we are now beginning to see.
Excellent. Do you want to talk a little bit about Vsan Direct before we move on?
Yes. Okay. Yes. And this is actually probably it didn't get as much attention, but it's a very important step from the Vsan innovation part. Vsan Direct allowed finally to run MinIO at very large scale. Applications team on smaller scale, it wasn't a big deal. You can run stock Vsan or Vsan SNA, but what problem that customers faced was when you want to bring in a heavy workload, could be a Veeam workload, or it's a Spark workload, or actually even Splunk workload, right? The problem that soon they faced was Vsan itself has a software RAID, and then running MinIO on top, you are again doing erasure code, and MinIO handles all the high availability capabilities, all the durability guarantees, consistency guarantees. It was actually kind of competing with the Vsan, doing yet another level of erasure code or replication. And this is not just true for MinIO. Every modern database, all the databases and data stores, even the message queues, all persistent services have gone scale out. When they went scale out, they took care of replication or erasure code at that layer. And this is where VMware realized that Vsan brought something very valuable to them, that is virtualizing the physical hardware, hard drive, or the NVMe drives, the storage layer, into the container layer was the true innovation that Vsan brought to the table. So IT can still manage when to upgrade, what's failing, and taking care of all the stuff. But the capabilities of like replication or erasure code are now offloaded to the MinIO or the persistent data store layer. What's the effect of this? You can run like 10 petabyte cluster seamlessly on VMware without paying the penalty. So it gives you host local access. All the writes and reads are directly going to the drive that is local to that container, and you get very good performance here. It's almost close to bare metal performance.
So let's take a look at that. Daniel's going to give us a demo of that. He's going to show us exactly how it works in VMware.
Hello, my name is Daniel Valdivia, and I'm going to give you a demo of MinIO plugin running on top of the Vsphere 7.0 update 1 version of Vsphere. So as AB mentioned and Jonathan mentioned, we've been doing this. We are cloud native since day one for MinIO, and we've been heavily investing on Kubernetes, and that has paid off because the integration that I'm about to show you, it's all running on top of the MinIO operator, running on the supervisor cluster of Vsphere 7.0, right? So right off the bat, what you're seeing on the screen is a very familiar, for those who know VMware Vsphere, a very familiar UI, right? Managing a cluster I have here. And now you'll see that a MinIO menu is actually now shown as part of the cluster configuration once you have activated the MinIO plugin. So, and from here I can go and see, for example, I can see if I've done deployments ahead of time. I already have here a small object storage cluster of 320 gigabytes. And for example, let's say I want to provision a new object storage cluster, right? I can make it extremely easy by following the steps on screen. And for example, let's say I'm going to be setting up some big data storage repository here, right? I'll be choosing a namespace to place it. The namespace construct from Kubernetes was also adopted by VMware, and that's now the new way for IT administrators to budget resources, right? So now they can say this much capacity can be used along this namespace. And then the familiar storage policies are also becoming present as storage classes, right? So one concept from VMware is coming to a concept of Kubernetes. And here I can see that I can pick the new Vsan Direct, right? The storage policy that we collaborated with VMware on building. And I'm going to show you setting up this tenant through the advanced mode, just so you can see all the features you can configure as you're setting up your cluster storage, right? The things you can configure, for example, are setting a custom image. This is pretty useful for air-gap environments, right? A lot of VMware deployments happen in air-gap environments, so being able to use custom images makes sense. You can enable Prometheus integration in case you want to collect metrics about your object storage cluster. We support identity providers, right? So we support two most popular identity providers protocols out there. OpenID, in case you want to use a single sign-on style solution like Okta or Auth0. Or if your company uses Active Directory LDAP, you can also configure it here by filling the fields that are needed. On the next step, we ask you about security. By default, we turn on TLS, right? We encrypt all the communication between the MinIO pods, and we manage all the certificates for you. Of course, some companies like to bring their own certificates and be in charge of all of that. We make it easy for you to actually come and bring your own certificates to control the security between the MinIO pods. Encryption, now comes the encryption question, right? So we support encryption at rest at MinIO, and enabling it is extremely easy, right? So once you decide to enable it, we support 3 most popular KMSs out there, HashiCorp's Vault, AWS KMS, and Gemalto. So if you want to enable encryption at rest, you can pretty much configure it in this step, and then it will be on, right? Last step is pretty much sizing my cluster, right? So if I hadn't gone into advanced mode, I will have gone from step 1 to second step, sizing the tenant. And where I get asked, okay, I have 6 nodes on this cluster, so it's offering me to use all of them. How big do I want my cluster? How much memory? Erasure coding features, etc. So what I'm going to do is just skip to that and then go to the last screen, which is a preview of what's going to happen, right? I'm about to provision 2 terabyte object storage. That's going to give me a 1 terabyte raw capacity usage with the default erasure coding features that we have. So I'll just hit create, and it's going to throw me some access credentials for my newly provisioned object storage cluster.
So Daniel, those
Yes?
nodes are actually VMs, right?
So yes, actually, yeah, that is correct. They did an amazing implementation of Kubernetes, right? So they re-implemented the kubelet as Vsphere. And what you think of a container on a regular Kubernetes cluster is actually a VM on VMware, right? But then the container images doesn't need they don't need any specialized optimization, right? So if you have any standard container image, it can run on this platform, and they will behave as containers in terms of Kubernetes. Underneath, they're actually a VM, right? So that is correct.
Yeah,
Okay, thanks.
One little data there. They actually, if you check out what's CRX, VMware Vsphere CRX, it's actually a lightweight container runtime. It's very much like how Amazon has this a Rust-based VM that actually gives you VM-like isolation, but container-like lightweight nature. VMware has that too. And when you are running inside the supervisor cluster, MinIO's containers are actually very light, a very thin, lightweight layer called CRX.
Mm-hmm. Yeah. So after I click provision, it's going to take a couple of minutes for the tenant to come online. Meanwhile, I'll show you other tenants, and I'll show you for example, this tenant that I already have here working. Seeing the details of it shows you the extent of the integration that we have, right? We can tell you things from how much storage is being used on that tenant, the endpoints that you can use to start consuming this object storage cluster, or if you want to go into the console graphic UI, as well as what's the state of the drives and the servers that you're using, as well if you want to expand the capacity of this tenant. So for example, if I go into health, I can see that for this specific tenant, I'm running it across 4 ESXi hosts, and then I'm using 16 locally attached drives that are actually provided to MinIO via Vsan Direct, right? So the data path to these drives is very thin, so that allows us to keep the high performance. And of course, if any of these drives was to be, something were to happen to the drive, I will figure it out from here, from this integration, and I could act on it and say, okay, fix that by either using a different drive or transition the server to a new ESXi host. So yeah, this is a demo of the integration that we have right now with VMware. And back to you, Jonathan.
Excellent. Thank you, Daniel. So that concludes the VMware demo, and we'll talk a little bit more about kind of graphical user interfaces. I think one of the things that we took away from that integration was that as we started to look at a broader audience, an IT audience, that we were going to have to expand what it is that we did, from a graphical user interface perspective. We grew up in the cloud native way, right? That's APIs and that's automation. That invariably led us down the command line proposition path. And so we built out a very robust SDK that allowed us to do a lot of different things. But as our reach expands into IT, we need to accommodate the way that they like to work on products with a nice, clean graphical user interface that they can check boxes, that they can see the health of that. It's the same functionality, but it's just fundamentally a different interface that they're used to. And so the challenge for us in building one of those graphical user interfaces was that we wanted to make sure that we included all of the functionality that we have, basically, that you can get at from a command line interface into that product. So we weren't making any compromises such that our developer community, if they wanted to, could use that as well. So it lowered the barriers to entry for IT. So they can use things like active-active replication. They can use things like the key encryption service. They can use things like the Sidekick load balancer very, very simply and easily, and they can understand sort of how their system is operating. From a developer perspective, now they can access really just through a URL Amazon scale infrastructure, and they can manage hundreds of petabytes to exabytes with just a single number of resources, very few resources. And it allows us to deliver both scalability and automation. And that's really how Kubernetes matures, I think, as a general rule. And then for our DevOps community, the ones that sort of brought us to the dance, so to speak, this graphical user interface doesn't diminish anything that we've done before. It just expands our audience, and they may find things in there that they find useful in terms of interacting with MinIO. So with that, I'm going to turn it back over to Daniel. He's going to show you what our new MinIO console looks like at this point.
All right. So what I'm going to show you now is that graphical user interface that we built for MinIO. MinIO being such a easy to manage, scalable, feature-rich software that it is, we found out that having a graphical user interface to expose all the features that MinIO has actually made it quite easy to consume, right? So I was mentioning earlier that Vsphere, when I was deploying my tenants on Vsphere, I was getting an endpoint to consume my object storage, but as well an endpoint to access the console. So for example, I'm actually I have the login prompt to the MinIO console, and I'm gonna log into it. And first thing that you guys are gonna see is that you're gonna be received with our Prometheus integration that's exposing some metrics regarding what's happening with your object storage deployment right now. What's the health of it? If there's any activity right now, this individual tenant has no activity, so we don't see much charts jumping up and down over time. But the main idea is this, right? You come online into your tenant and you want to know if it's healthy, if something's going on, if there's too much traffic, right? If anything's choking, if the server is down, that pick you get right as you log in immediately. Right, so console not only gives you, it's not only about telling you what's under the hood, it also exposes an object browser. So if you want to see what's going on with your buckets right here, I can see I have a bunch of buckets, and I can go into the buckets, probably download one of these files, or if this, for example, this is a version bucket, so if any of these files have been uploaded multiple times, I will see the file versions and I can download them. I can also upload new files. So this is pretty similar to the MinIO browser. It's just that we have improved it to match all the new features that MinIO supports. Also from console, I can do things such as generating service accounts. Service accounts are a way for administrators. Yes?
So Daniel, can the MinIO console manage the Vsphere MinIO cluster? Or is that?
Yes. So what you're seeing right now is a management UI for MinIO, right? So this is a console deployment exclusive to a MinIO instance to manage all its features regarding object storage technology. But as I mentioned before, our Vsphere integration works on top of our Operator technology for Kubernetes. And for Operator technology, we also have developed an Operator UI that I'm showing here on the screen, which you can see resembles pretty much the same features as Vsphere that I was showing you. And because it actually exposes the same features, right? So we have a way, oops, I got logged out. Luckily, I can log in the IDP very quickly. So it exposes the same set of features to set up a tenant in a very easy way. And this is entirely Kubernetes-based. So the same console technology can be used for orchestrating tenants. Once a tenant gets deployed, here you can see the endpoints. I can go into this specific tenant version of the management console. And then that will give me all these other features that I'm showing you here. So you can see the menu is more rich because for this one tenant, I'm managing the users. It has a different set of tenants, but let's say you provision a tenant for a smaller data science team that's only doing some small experiments. So maybe they have their own object storage, right, with their own console and their own set of users and rules and everything. And that's very easy to do. And of course, just to go back to your question, yes, this console will be able to manage both type of scenarios.
All right,
Yeah.
thanks.
One point to add there, if you look at how Amazon works, if you model that, right, now what Amazon engineers do behind the scenes is what you do through the Vsphere vCenter UI, right? Now we cannot expect our customers to hire Amazon class engineers, and even if they can, it is just not productive and it's expensive, right? It's not scalable model. So how can we make the IT do the stuff that Amazon engineers are doing at scale in a way that's super easy, all from the vCenter UI, right? That's what you saw from the vCenter UI. That's basically replacing what Amazon engineers are doing for themselves. And what you do from vCenter UI, you can also do that on a stock Kubernetes entirely outside of VMware. If you deploy MinIO on the stock Kubernetes, the operator UI Daniel was showing right now is equivalent of the vSphere vCenter UI. But if you're a hardcore Kubernetes DevOps, you would actually say, I don't want a browser interface. I SSH and operate on my terminal. I want a kubectl interface. All these underneath, they use Kubernetes API called, basically every Kubernetes resource publishes a CRD. CRD is a custom resource definition where you basically introduce your resource, your object into Kubernetes as a standard API object. So you can use kubectl interface or the graphical operator UI, what you see on the screen right now, or you use vCenter UI, they all coexist.
Thank you.
And once it is installed, now you go to Amazon console as a customer. Now you have a customer admin like a DBA, right? Installing the database is one job, but managing the database is a DBA job. Similarly, when you log into Amazon console, if you are the administrator of your object storage infrastructure, you would set policies and grant access and stuff like that. That is self-service. Either IT can continue to keep control of it, or you could grant that access to the application team so they can self-service exactly how they would do it on AWS.
So AB, a question here. So does it mean that if I want to build a full multi-tenant object store today, I have to deploy Kubernetes and then on top the MinIO Console, and starting from there deploying all the MinIO clusters on top of it? Is this the best way to operate?
Spot on. Yes.
Spot on, yeah.
If you are looking at a single tenant, right, probably Kubernetes is overkill, right? If you are looking at a single tenant and fairly static, it's not static in the sense you have deployed it to handle, say, one year, 2 years worth of storage. It's a cluster you deploy and you forget it, and then you just start dumping data in it. It's much easier to just run MinIO, like it runs like a web server on a stock Linux distro. It's just much simpler. But the moment you are looking at a multi-tenant self-service cloud storage in service, right, then Kubernetes, you cannot beat Kubernetes. That is really where the MinIO's operator comes in. And a simpler way to compare and understand is, if you have a database, a Postgres server, for example, or a Microsoft SQL server, you have a single database, you deployed it, you're a DBA, you create tables and now databases and tables, it's well understood. But the moment you want to do DBaaS, database as a service, where multiple tenants, customers, multiple applications coexist, so you run multiple databases where the provisioning, database, snapshots, all of that is automated in a way that application developers don't care. It's always highly available. It's automatically snapshotted. Any failure, it will auto-recover. That is the infrastructure responsibility, not application team responsibility, right? Similarly here, managing multiple tenants of MinIO, how you upgrade, update, apply security patches and scale, all of that is the infrastructure team's responsibility. Consuming it is applications team responsibility. And when you have that multi-tenant requirement, exactly what you described is where Kubernetes has become the industry standard as one universal framework to build cloud native infrastructure, and MinIO takes full advantage.
Does it mean that MinIO Operator can also manage the cluster, after the initial installation? So including, yes, you said patches, but also cluster expansion, for example.
Yeah,
I saw that you manage the storage classes probably to give more performance to one cluster instead of the other. But actually, if I need to expand the cluster, is it possible from the UI?
Yes, and that is what the operator does. In fact, operator has all the logic, right? So without the operator, so this is actually a Kubernetes construct itself. If it is a stateless container, it's fairly easy. All stateless containers are fairly similar. So you want to scale, you can auto scale. Just run more containers, deploy them anywhere. As long as there is enough CPU, memory, and network resource, Kubernetes knows how to manage it. What Kubernetes does not know is manage stateful containers, because stateful containers, managing Cassandra, managing a Postgres database, managing Elastic or Kafka or MinIO, each one of them, they have different ways to upgrade, update, scale. Some will do erasure code, some will do replication. This knowledge cannot be automated by Kubernetes itself, but that's where Kubernetes allows you to build an operator that captures these DevOps script. Otherwise, on a bare metal, here is where Ceph, Puppet, Ansible scripts come in, but then you hire these engineers to do all their job and they leave the job and go, no one knows how to take it over, right? But an operator captures the job that a typical DevOps would do, so you don't need to hire a DevOps into your organization. If you have, it's great, but their job should be productized in a way that it is repeatable and anyone can use it from a web UI. So when you do these operations to scale a tenant, deploy a tenant, upgrade a tenant, you are essentially doing the DevOps job. Who is doing the DevOps job? That is productized in the form of operator, and it's a standard Kubernetes construct.
Well, I just want to throw a summary of the things that you guys didn't go to see, but essentially all the administration features that MinIO has, healing, diagnostics, configuring buckets, adding user setting policy, like Evi mentioned, all of that powerful features are also available through the console graphical user interface.
How important, it's interesting that you're developing the GUI, but a lot of what you've talked about has been kind of how MinIO has been adopted, and part of its success has been its adoption by stealth almost, and that discussion around how that integration with VMware and almost just being a native thing that happens in the background. How important do you see that as part of your continued success versus the idea of becoming more in people's face, for want of a better phrase?
So I think, again, the audience that brought us to the one who brought us to the dance was the DevOps community, and we're going to continue to invest in our SDK, in automation. Automation is a huge part of what it is that we do. And so we're not going to in any way leave that community. We're just expanding that community to reflect where we are in the marketplace these days. VMware has brought us into this IT. They've given us the keys to the IT castle, and we're going to pick those keys up and we're going to use them. We're going to open up the door and we're going to walk right in. So it's really, it falls upon us to now service both of these audiences equally well. All right. So I think subnet is a really important part of this. We have two sections. We've got the subnet demo, and then we've got hybrid cloud. And I think that if we work quickly, we'll be able to get through them all. But subnet's incredibly important because it is the commercial engine for MinIO, right? It is how you consume MinIO, how you interact with MinIO in a production environment. It combines a commercial license, again, giving you relief from the AGPL v3 obligations, coupled with an unparalleled support experience, which we're going to show you a little bit later. This was an area of great interest last year. Ray, in particular, spent a bunch of time talking to us about this and challenging us on whether or not this is going to be scalable. And we're going to show you some reasons why we think not only is it scalable, but it's scaling very well. But you get direct to engineer access in this model, 24/7, 365. It may be a 24-hour SLA or a 1-hour SLA, depending upon what program or package you choose. But you're going to be talking to the person who wrote the code and who can help you with minimal friction resolve that problem. It is priced just like the public cloud. In fact, if you go to MinIO.com right now and you look on, or min.io right now, and you look on the pricing page, you'll see exactly how much it costs. And there's calculators that allow you to make that determination on the reference hardware page. So it's just like the public cloud. It's billed monthly. You can cancel anytime. You can scale up. You can scale down. And it's very transparent. We have a bonus feature in there, which is that at 5 petabytes or 10 petabytes, depending on what plan you're on, we're going to turn off the capacity meter. So that creates a ceiling at $1.2 million for your software costs. And that, by the way, creates a huge incentive for large-scale data repatriation. If you're like one of these organizations who's paying $100 million a year to AWS, and you can basically, for hardware and software, spend $98 million and get the exact same experience with better control and perhaps even enhanced security, that's going to be a very, very compelling proposition. And we think that that creates a real incentive, again, for large-scale data repatriation back to the private cloud and on MinIO. Now, the reason that Subnet works is because of software, right? We have focused relentlessly on making a great software product. We only do one thing. We do that thing very well. It's simple, powerful object storage. Simplicity is a core component of it. If you have a simple and powerful product that works and does exactly what it's supposed to do, you document it exhaustively, and then you put automation in every little component, you can actually solve this problem, and it creates a culture of real-time, always on, and it allows you to scale this thing the way that we've scaled it. So last year, the challenge was, could you scale this to hundreds of customers? Listen, our customer growth number is up 606% year over year. That's split almost evenly between the standard and the enterprise. Again, the SLA being 24 hours and 1 hour on that, but a pretty even split there. Even with all of those customers, our average number of tickets today that we're consuming is 2.65. Now think about that for a second. We're talking about dozens upon dozens upon dozens of customers, and the average number of tickets is 2.65. It's because we built great software to start with, right? Our average response time is less than 15 minutes because our tickets are manageable because, again, we built great software. And we're supporting more than 350 individuals across those different clients, another 11,000 on the Slack channel with no SLA there, but we're supporting all of these customers again, and we can do that because we built great software. If you look at the bugs that we do get in, about 25% of those are sort of general bucket, really hard to categorize. 18% really involve extending MinIO, right? That's configuration and enablement, where they want to go do some new workload, or they want to put us onto some new type of hardware. 13% end up, frankly, as user error, but we're helping them anyway, because that's what you get when you subscribe to Subnet. You get a white glove service. And then 6% involve what we would call bug fixes. These are not showstoppers. These are things that we can do better, or kinks in specific configurations that we haven't seen before that we generally can fix relatively quickly. But that's what Subnet offers, and it allows us to scale this model remarkably well and to service our customers in a way that they become forever customers of MinIO. Our renewal rate is, it's extraordinary. I don't think it's quite 100%, but it's pretty close. And the net revenue renewal rate on that is certainly well above 100%. And that's a function of the fact that we're doing an incredible job in this model, and we're able to scale this model. So AB is going to take us through the next generation of what it is that we've done. We've added some really critical features to the capability set here. And so he's going to grab control and show you basically what a subnet demo looks like.
I'm going to log in through one of the demo accounts so I don't accidentally show any customer information. So this is how you log into Subnet, and Subnet is a service. And the philosophy behind Subnet is the value of software is not the big deal here, right? It's how you operate and consume MinIO. Value has shifted from just software, source code binaries, paying for licenses, to how it is operated and consumed at scale. And that's really the reason why customers pay. They pay us because we solved a business problem and we gave them value there. And when you operate at scale, you do not want to lose data or have a data breach. Of course, you also want to not have a software license violation stuff, right? So Subnet is how the entire subscription is packaged, and then they connect with us. It's an end-to-end customer success platform, starting from how you buy the software and pay for the license subscription renewal. All of that is in the subscription managed management and how you automate your payment even on a monthly basis through this interface. Then you can bring every member of your team into the system. It's not like only the designated admin can actually have access to the support system. It's important for your team, like it could be a QA member, or it could be a developer or an InfoSec team. Everybody collaboratively solving the problem is critical to operating your infrastructure, right? And when your problems are found earlier, if a developer makes a request, it should be the same level of SLA as a critical security requirement coming from InfoSec team. And all of the requests are actually coming with the same SLA, same priority, right? As you collaborate, like you engage with us, everything happens in real time, and your team and our team collaboratively engages in solving these problems. It's almost where Slack meets Zendesk. And the traditional support systems could not scale to manage real-time operations, because a 30-minute downtime in infrastructure is actually it makes headlines for them, right? Their infrastructure cannot go down. And how do you keep that level of SLA? How do you get to minutes level SLA? This is where this collaborative approach to operations comes in. Customers look at us as an extended part of the team, right? Even there is an instant SLA when you click the panic. I'm not going to do it because it will wake up everybody across the MinIO team worldwide, right? But now, how do you scale this, right? Of course, when you engage your team and our team, when you go to 1,000 customers, now how do you deal with this level of load? We have already demonstrated, even on the community side, there are 10,000 plus members on the Slack channel, and the number of issues that get opened and closed on a community GitHub, you will see it's probably greater than all the other object storage vendors put together. But how do we give a premium white glove service for the paying customers? This is where the heart of the new Subnet 2.0 interface, right? That's what you're seeing on this screen, that we make supportability itself as a software problem. Supportability capabilities are actually built into MinIO software, and the diagnostics capability, right? When you have a problem, it could be a hardware problem. In fact, majority of the times we find that some drive is slow, network is slow, or bad drives, and all kinds of infrastructure problems are also our problems, even though we are just a software vendor. End of the day, data infrastructure down means it's on our head, and if we cannot do finger pointing here, right? We have to collaboratively work with them and find out what went wrong. The moment I told you, hey, it's a bad drive, or the new batch of drives are 30% slower than the previous batch of drives, if I gave you a root cause analysis of what the problems are, and even proactively told you before you even saw the problem, that is when customers are happy and our cost goes low. It's almost like I'm running an insurance company and I gave you free gym membership, and if you lead a healthy life, then it's better for me, right? I save money. And that is where this Subnet 2.0 interface comes. And the clusters, when they are registered, with a click of a button, it will actually do a multi-point inspection inside the cluster, and it will actually click on, it will actually perform the diagnostics from inside the MinIO cluster, and it will produce the analytics output into the Subnet console, and we can actually tell exactly what went wrong in the system. It will do a point-by-point analysis. Could be as simple as some drives are slow, or say on some of the nodes you are running an old version of MinIO because the upgrade you didn't go through, maybe that node was down and now it's back online. All kinds of problems that, like from a support personnel, humanly, if you have to go and analyze all these multi-point inspection, it's going to be pretty difficult, right? And time consuming. Instead, if you throw software at the problem to do the diagnostics, customers can self-support themselves because they can see what went wrong in their environment, and then they just, if it's a bad drive, you know how to get an RMA process going, right? And if it's a software bug, then you go and file an issue, and then it's the shortest path to resolution because we know exactly what went wrong.